Okay, today is about composition of functions, and that's where you do f of g of x, kind of like this. But it's more importantly about how to do the domain of those. That's what's going to be difficult for today. I brought my A game today, okay, because this is not easy stuff, but I got good examples for you, and it's going to work. All right. So first of all, if I just add functions, it's super easy. You know, f of x plus g of x, that's too easy to even do. It's not worth doing. But let's do the subtract one because somebody's going to mess up the parentheses. Everybody, please just do g minus f of x. Not talking about the domain right now. Just take the g function and subtract the f function. I'm going to pause for a second. So hopefully, when you took g minus the f, you took this one, g, which I don't even write the g, but some people are talking out there. Don't make me yell at you. Thank you. And then I subtract the f function, which is that, and then I'm going to put parentheses around it. That's what I was trying to catch a few people on. Is it because I want you to have pain? A little bit, because I want you to have pain now so you don't screw it up on the test. Okay? Don't forget the parentheses. I know I caught a few people on that. All right, that parenthesis makes this negative get distributed. So final answer, the negative x squared doesn't have anything else to go with, so it's just in my answer, negative x squared. Then the negative 5x goes with the positive 2x and makes negative 3x. And last but not least, the 16 and the negative 40, which makes positive 40. Positive 40 and the 16 makes 56. Raise your hand if you had that one. Awesome. Okay, next, we're going to make the f function eat the g function. So we have f function, which is right here, empty spot squared plus 5 empty spot minus 40. That's how I think you should do it. You take the f function, which was this one, and you make it with empty spots where the x is, and then make it eat the g function. Poor little g of x has been devoured. But I don't put g of x there. I put what there? 2x plus 16. And then 2x plus 16. Let's just save the time. I think you know you would multiply that all the way out. That's good enough. Okay. On the test, yes, you'd multiply it all the way out. But let's save the time. All right. Would you please write what you think, then, g of f of x is? This last one. Give it your best shot. I'm going to pause for a second. Let me give that a try. Okay. So, g of f of x, gentlemen, I know I opened up a can of worms there, but I need you back with me. Control. All right. So, g has the honor of eating the f function. Here's the g function with an empty spot where that's like his stomach, and now he's going to eat the f function. X squared plus 5x minus 40, and you'd multiply it all out. Okay? Any questions on that? Hold on. Oh, that's a 16. My bad. You just couldn't read it. It was a 16. Okay, anyway. Now, I'm going to move on to just one like this. They're super easy. It's G. It's got a weird like way of writing it, though, and that's the what we've got to get used to. Do you get that this would translate to G of f of 1? If you translate the little circle to an of, it helps. G of f of 1. So then, wouldn't you just start by figuring out f of 1? Yeah. Do that. It's really easy. G of f of 1. Don't feel obligated. You're fine. G of, and an f of 1. I'm going to stick in a 1 into the f function, and that's right here. And hopefully you came up with 1 minus 4, which is negative 3. Raise your hand if you got that far. Awesome. Now we just have to do g of negative 3. Okay. So g, which is this function, I'm going to write it with an empty spot where the x is, and I'm going to drop in a negative 3. And then, ooh, square root of 0. Does that like break a rule or something? No, it's fine. It's just 0. Final answer, 2. Raise your hand if you had that one right. Okay, good. If you got lucky enough to see that on a test, it would definitely be an R2. Super easy. All right. This is a diagram that I like things that are visual, but you are not ready for this. It's sort of like people that are just starting to learn the basic parts of the human body, and then they're like shown, you know, I don't know, the circulatory system. You're not ready for that yet. Okay, I'll get back to it when you're able. All right, this is the part where I've made up what I know are functions that are going to work well for our situation. Would you write this one down? You got f of x is the square root of x minus 5, and g of x is x squared. So if I say f over g of x, I divide the two functions. This isn't that hard. Just figure out what f divided by g of x is. You just divide the top divided by the bottom. And there's no big trick here or anything. I'm going to pause for a second. We give that a try. Okay, so f is on the top, and you should have had square root of x minus 5 over x squared. Raise your hand if you had that one right. Awesome. Now, you would think that you could just look at this and say what its domain is by saying, okay, I did a problem like this on the test. You did. You had a problem like that, and it said, what's its domain? But you can't do it that way because we are getting into territory where you can't just look at the answer and say, oh, I can see what its domain is. You have to follow certain rules. So here are the rules that you have to follow when you are doing the domain of this function. You ready? All right. So I have to know what the domain of f is. Everybody underneath f of x, write d sub f. Take a wild guess what that stands for. Domain of f. Colon, we don't put equals on domains because it's not like an equation. The domain of f is, and then this part, you should be able to tell me what it is because it's implied. That's called implied domain, meaning you have the little rules to say, oh yeah, the thing underneath the root, how do you do that again? Thing underneath the root, x minus 5, is what? Greater than or equal to 0, and then you solve that, and what is the domain of f? Write it there when you've got the domain of f. Okay. Should add and 5 to both sides, and you have x is greater than or equal to 5. Raise your hand if you had that. All right, good. Somebody in the back row is not paying attention. I need your attention. Be with me. And in a moment, I'm going to ask you to turn your iPad my way, and if it's got like a picture of Mickey Mouse, I'll not be happy. All right. G of x is x squared, has a domain also. Would you agree that g of x has a domain of everything works? Can't crash that thing because it doesn't have a square root and it doesn't have a denominator. Just remember, sometimes the most confusing ones are the ones where you can't crash it. The domain is then, therefore, all reals. How do I write that? There's three ways. A number line that's shaded in everywhere, a negative infinity to a positive infinity, but the way I like best for today, because you can use multiple ways to write things, the way that works best, the notation that works best, is an equation. Okay? And x is big R. Do you get that means x is equal to all real numbers? All right, so write equations instead of number lines, instead of whatever for today, because what we're doing today is a little more intense. Number lines are awesome, but we will only use them at the very end. Okay, so we have found the domain of G, dg, to be x is all real numbers. Now, I get this concept across to you the other day where this is like the child, and these are like the parent functions. And do you get that there are some things that are hereditary? Hereditary weaknesses, like in humans, your mom's had cancer, your mom's mom had cancer. Oops, you better watch out, you might get cancer. And so you probably should watch out, like as in get regular checkups, because if you get the cancer and you catch it really early, you can survive it and be okay. It's just if you catch it really late, sometimes you can't. So point is, I actually know that because I have that in the family, and so we got to watch out for that. Anyway, in this case, what is the weakness? The G or the F? Which one has the weakness? F does. And if you feed F things like 4, anything less than 5, it's going to crash, and therefore its child here is going to have that weakness, but the divide kind is more complicated. I showed you add, subtract, multiply, but I didn't do any divide problems all the way out with you because they didn't have time yesterday. So let me show you what happens when you divide. When you divide two functions, you have to take the domain of the top one, the domain of the bottom one, and a third domain, and you see where they all three intersect. Does anybody remember the thing I said yesterday? The third domain? Something about zero. What? You can't have a zero on the bottom. Very good. The domain where G cannot equal 0 is the third domain. Do you get that it would have been okay for this to be 0? Do you get a 0 in there? Doesn't really cause a problem to the G function. But now that it's the denominator, you can't let it be 0. You get the difference there? As G function all stand alone by itself, it's fine if it's 0, but not when it's the denominator of this f over G function. So you need 3 number lines. We use number lines at the end. You'll see in a minute why we have to use equations instead of number lines until the end. This one, we probably could have been okay with number lines the whole time. But the ones we're going to get to, the hard kind, number lines won't work for the middle part of the problem. Now, at the end, you can just make 3 number lines and see where they all overlap. What's the domain of f number line? 5 greater than or equal to 0. What's the d of g number line? All reals, and so you just fill in the whole thing. Make sure it's clear that it's not an empty number line, but it's been scribbled in. And then last but not least, the extra thing that we didn't used to have to worry about, but now we do, is what would make the G function 0. And just to clarify, in this case, 0 is what makes the G function 0. But do you get if the function had been, -7 would have made the G function 0. So I just don't want you to think that just because this one is 0, 0 is the thing that makes this equation 0. It's not like it's always just 0. It's whatever makes the bottom function be 0 is the thing that's not allowed. All right, now I'm going to move this 5 over a little bit just because then the 0 and the 5 are matching up better. And here's the question. There's a zone here out past 0 and all the way to -infinity. Be careful now. There's a filled in arrow down here. It looks like it's filled in, but it's not okay for that one. Oh, wait, it is okay. Sorry, my bad. It's not okay here. So therefore, since it doesn't work in all 3, that zone's out. It's not in the domain. Has to work in all 3. So where's the area where it'll work for all 3? Between 0 and 5, is that zone okay? Nope. But from 0, which I got to be more careful here, this is filled in right after that. From 5 to infinity, that's the zone that actually works. 5 to infinity. And then all that work, and I lose 5% at minimum. What did I do wrong at the very end? Bracket. Bracket on the 5. That's all it takes. Be a little careless with the bracket. All right. Moving on. What if you had just done one of those divide problems, and you had gotten these 3 number lines, d of f, d of g, and the domain of g can't be 0. And they were filled in correctly like this on the number line. Would you figure out for me where do they all overlap? Like your answer might be from 5 to infinity, or your answer might be from 2 to 5, and then 5 to infinity, etc. Write an answer like that for where do these 3 overlap. Make it an interval notation. All right, and pause for a second. Let me give that a try. Okay. The first zone is from 0 to 1. Are all three of them intersecting there? Nope. How about from 1 to 3? Nope. This one doesn't work. It's not shaded there. Get what I'm saying? Okay. How about from 3 to 4? But does 3 or 4 work? So you go 3 to 4 with parentheses. Raise your hand if you had that. Nice. Okay. Then how about from 4, easy mistake to make, 4 to infinity? Nope. How about from 4 to 7? 4 to 7 does work. Does 4 or 7 work? Nope. And then last but not least, 7 to infinity, right? No, because the top one's not shaded, so that doesn't work either. So it's just these two, and you'd put a little union sign in between them. 3 comma 4 union 4 comma 7. All right. Oh, yes. Yes, it is. It's right there. You're correct. It's okay. It was there the whole time. It's because I used this example last hour. So. All right. Take a look at this. It's a f function and a g function, and it's got something different. I've already done f of g of x. Did I do it right? And then we are going to figure out how to do a domain for this, which is a completely different thing. You do not just overlap 2 number lines, or even 3 number lines. There's a formula that helps you to get these right. This is not something that most people would on the street would know. Pretty much math teachers and maybe even math professors, because they're beyond it, and so they probably forgot this formula or whatever. But math teachers in high school are pretty much going to be the ones that you could find who would know the formula for this. Or kids that are about to take the test on it, like you. Because if you don't know this formula, you're not going to get that one right. You have to know the formula I'm about to give you. Okay, so this is one, I'll tell you, when you got to memorize stuff, we really try to not make this course have a lot of memory in it, like, because we know you can Google stuff nowadays. But honestly, this is complicated enough that it'd be very difficult to even know what to Google to figure out this formula. And there's a few formulas here and there you're going to just have to memorize. All right. So if you haven't already written this down, write it down. And did anybody find a flaw in my f of g of x? Did I have the f function eat the g function properly? Yes, I did. Okay. Now, next part. If I want the domain of this, which is called a composition, it's composed of 2 functions. If I want the domain of this composition, it depends on the domain of f. I hope you're getting used to df, meaning domain of f. And could you figure out the domain of f? It isn't given, but could you figure it out based on how it's implied? All right, so figure out the implied domain of f. And then figure out d of g. That's the implied domain, or sometimes it isn't implied. Sometimes it's just smacking you in the face. It isn't like, well, I would assume you'd know that. Sometimes it just says, hey, on this one, x is greater than 3. That's the domain. It says so right there. That's not implied. Like if I said, hey, could you come in at 12 o'clock? To get it's kind of implied that I'm not talking about midnight. You know what I mean? Implied means it's sort of not said, but assumed you would know that. Okay? Versus this one is just stating what's called an artificial domain. Do you get the 2x cannot be crashed? But they can still give you what's called an artificial domain, as in, you wouldn't know this, but we want x to be bigger than 3. So it forces your hand on what the domain is here. Here, hopefully, you were smart enough to go x minus 5 is greater than or equal to 0, x greater than or equal to 5. We just did that one a second ago. Okay, so now I got my 2 domains. That's what you want to start with, is find the 2 domains. but you are not, oh, I wish it was that simple. Just going to make a number line for this one and a number line for that one and see where they overlap. It's not that simple. Okay? So this formula I'm about to give you that finds the domain of your new function, the domain of the new, will be domain of the inside function. Do you get that? It depends. It isn't always f of g of x. Sometimes it's g of f of x. It's domain of the inside function intersected with the inside function. Notice I didn't say domain of the inside, did I? The inside function in the domain of the outside. I know that's a lot. Let me give you a real-world example. This problem we're doing right now. Do you get what I want is the domain of f of g of x? In my case, that's the new function we have created. You want to keep copying this because you need one good example to go back to. The domain of f of g of x is, what is the domain of the inside? That, in this case, would be d of what? Which one's on the inside? G. So therefore, d of g intersected with, what's the inside function? G, and we're going to say g of x. Could have just said g, and it would have meant that, by the way. In, what is the domain of the outside function? It's the domain of the f function in this case. Now, we actually have to do these things. I have enough room on my board to write this, but barely. I'll scroll up after that. Domain of G. Oh, I've got that. Because I started with writing what the domains are, that's what you should do. Write down the domains for each of the parent things first. X is greater than 3. It needs to be intersected with g of x, which is what? It's on the board. Just look for it. Where's g of x? 2x. 2x in, and what's the domain of f? Right there. X is greater than or equal to 5. Now, there's two hard parts to this. One is knowing what the formula is. Number two, sticking everything in, that's pretty easy actually, is figuring out what the heck this means. It's really not that hard. X is greater than 3 has to be intersected with 2x in x is greater than or equal to 5. If I was going to put it into it, where would I put the 2x in there? The 2x will go in where the x was. So now it's 2x is greater than or equal to 5. Then I divide by 2, and I've got x is greater than or equal to 5 halves, same as 2.5. Now that I got it down to those two, I strongly recommend number lines, because seeing where things overlap is really pretty easy on a couple of number lines. So here's a number line with a 3. Here's a number line with the 2.5. And now, if I want to see where they overlap, I go like this. And I make sure 2.5 is to the left of 3, isn't it? So I got to make sure I have my number lines lined up. Like, do that, and everything gets messed up. It's like this. And now, does it work in this zone? No, nothing works in there. Does it work in this zone? No, only one of the two works in there. So where does it work? This zone, which is what? X is greater than, does it have to be or equal to? Does equal to 3 work? No, because of this empty spot here. So X is greater than 3. I know. It was the same as this one, this time. But it isn't always. You can't just count on that. It happened to be the more restrictive domain of, well, actually it's not more restrictive, it's just different than the other one. All right, so now here are some thoughts. First of all, do you remember the formula well enough to do it backwards? Don't say the answer, but see if you can actually do this. This time it's going to be g of f of x. The f of x is on the inside. What's the formula for its domain? Formula for the domain of that. This is where it's powerful to have taken notes. Some of you have a good enough short-term memory that you still have it. Everybody's got the last 7 seconds. So in other words, whatever's happened in the last 7 seconds, you can usually say it. That's why somebody is totally not paying attention, and you go, "Hey, you," and they go like, "Somebody who's totally not paying attention." Like they can repeat what you said for the last 7 seconds. Okay, but some people's short-term memory is way longer, and if you're that lucky person, awesome. But it's all about long-term memory, anyways. I mean, that's what really makes you learn stuff. I teach it to you today, and you have an awesome 24-hour memory. Then tomorrow at this time, you don't know it anymore. You know what I mean? It's about long term. Okay, let's see if you got it right. Domain of the something intersected with something, something, something. Who can finish this thing? Raise your hand if you can. Come on, you big chickens. I know a lot of you can. Why don't you give it a try? ML. Okay, but what is the inside? So D of F intersected with f of x in, careful, in, it has to do with g, but not, it's not in g of x. D of g, and that's different. You were close. 12-minute warning. Wrap it up, server. All right. So, d of f intersected with f of x in d of g. Questions about that? That's what the formula would be. So let's try that out. But look at this problem. Notice this time I have g of f of x. F of x is the inside function this time. I did not give you the domains. You figure them out. First thing I would do, figure out domain of f. Then figure out domain of g. Oops. Then, hopefully, you can figure out the domain of g of f of x. Give it a shot. If you don't try it once yourself, how are you expected to be able to go and actually do this on a test? All right. First thing, domain of f. I know how to do this kind. X minus 5 greater than or equal to 0, x greater than or equal to 5. Domain of g. Hey, it tells me the domain of g right there. X greater than 3. This is a lot like that other one. Except this is the backwards one. G isn't on the inside, f is on the inside. Hopefully you use the right formula. You start with the domain of the inside, domain of f, intersected with f in domain of g. Okay, what is the domain of f? X is greater than or equal to 5. Intersected with f of x. Which one's f of x? This one. Square root of x minus 5 in, what's domain of g? See how it's really handy to have all this stuff done ahead of time? X is greater than 3. Now how do I put this in that? Square root of x minus 5 has to be right there, greater than 3. Now some people get like stuck right there because they don't know how to solve that, but it's really easy. What do you do both sides here to get to the next step? Square both sides. That's how you get rid of a square root. This is where some people are like, okay, pre-calc just kills me because they don't have, like, for most people, they're like, oh, I just square both sides. But if you don't have a clue that that's how you solve an equation like that, then you get stuck in the middle of a problem and you have no hope. Okay? Because you can't go, if you can't do that, then you don't know how to get the answer and you're stuck and you're not going to get it right. And why? Because of algebra. That's why I really hit hard on that top 20. And some people don't believe me, and they're like, well, I'll get it someday. Well, if you don't get these little algebra basics, then you're going to get stumped in the middle of a problem and not be able to solve that part, and that means you get the whole pre-calc problem wrong, even though it was just algebra. Yes? Nope, because we squared both sides, not square rooted both. If you square root both sides of an equation, that's where you get the absolute value, and I'm glad you remembered that that's a thing, but we squared both sides. That does not cause an absolute value. Okay, and then it's x is greater than or equal to 5, and x is greater than 14. How many of you got it that far? Sweet. Then, from there, now, you have to put those two together. Here's 5. Here's the 14 one. I'd like to make it over here. Oops, empty circle at 14. That's important. Filled into the right. And now I'll just grab this one and move it over. Nope. There. Underneath here. And then I see where they overlap. And in this case, x is greater than 14. Now, some people still feel like, okay, they think they got a shortcut on this and they can skip all that junk and just do this. They go, okay, I'm going to make the g function, eat the f function, and I'm just going to look at that and see what its domain is. I'm trying to find the domain of this, right? So why don't I just look at it and say, what's its domain? It's not that simple. You got to go through this process and you'll find out, what was our answer anyway? X is greater than 14. Would you have looked at this and said that the domain of this was x is greater than 14? No, you wouldn't. So the point is, you can't just look at your new function and say, what's its domain? You have to know this rule, this way of doing it, to make sure what's going to poison this function. Yes? Interval notation would have been fine for that, yes. In other words, the answer could have been 14 infinity like this, and that would have been just fine. All right, I know that was pretty heavy duty. Now I'm going to cut your assignment way back. I only need you to do a few practice of these. So find your assignment with me. I believe that's the first page. Is that the first page you guys see too? Okay, find it. The one that says PDF HW for homework. We are skipping number 1 because, frankly, it's too easy. The domain on number 1 is all reals for x squared, nothing can crash it, and all reals for that. What do you think when you overlap all reals and all reals? The answer's all reals. And then when you put it inside the other one, and it's like all reals. Whenever there's nothing wrong with the parents, like there's no weaknesses of the parents, then the composed functions won't have any weaknesses either. So bottom line, it's too easy because it's all reals on both of them, and that makes all your domains like too easy. So we're going to do number 5. Sorry, yeah, I did do this in the other hour. And we are going to do number 9. Nope, we're not. Sorry. I did it in one of my hours, but I'm not doing it here because we have less time. So we're doing number 5. We are doing number 19. Look at this for a second. We've never talked about absolute values, but should that stop you? No. You're asking yourself, what would work in here? Can you think of any number you could put in that would kill an absolute value? No. So it's really not that hard. That side's all reals. Except it says this. It would have been all reals, but then they threw in that what's called artificial domain. So it's got an unusual domain. This one has an implied domain. Like, well, of course you would know that 4 minus x needs to stay greater than or equal to 0, because that's implied. All right. All right. Then one more. I'm going to do this is a lot shorter than the other one, is number 16, because it's only got 3 parts. And I don't even need to do this one. Cross off the last one. Okay, got to admit, that's about less than half of what was normally supposed to be assigned. Now your job is to actually do that part. Now one last thought. This Friday is the last day to switch. So if you're like, this is so far over my head and I can't even get half right on the top 20, this is your last chance to switch, because this is kind of typical honors pre-calc. Okay, you got to decide if it's worth it. Almost everybody in here should stay. I can't say who should not, but you have to decide that for yourself. If anybody in here can do it, but do you have the time to put in to do it? Okay, so that's all I got for you for today.